Hello, everybody. My name is Ahmad Nassri. I'm the CTO at NPM. I come from Toronto. I'm visiting this beautiful city of New York. I do a lot of things in the community, in the open source community. I contribute to JavaScript. I create my own packages. I contribute to other projects. I organize conferences like this for developers and people who build developer tools. I'm here to talk to you a little bit about modular JavaScript and building modular software and practices around that. But first, I want to get into definitions, because we often get confused in our industry a little bit about defining what we're talking about. And modular is a thing that kind of attributes to a lot of different meanings. So first and foremost, what does modular mean? If we go back in a little bit in history, we have this Unix philosophy that emphasizes on building things that are simple, small, easily shared, and more importantly, easily maintained by people other than the developers that created it. What that gives us is a set of practices that we can look at and learn from that we should adopt in the way we build software today. So specifically, the things I want to highlight is what modular is not about. So let's start with that. I'm not specifically talking about modules equals packages. There's a lot of overlap in those terminologies, but there's a little bit of a intersect between them, so I'll get to that later. Modular architecture is not necessarily about microservices particularly, but it does, again, relate to it a little bit. There are such a thing as modular monoliths, so it's not necessarily a one-to-one relationship. Modular architecture is not necessarily the same as modular software. You've heard a lot about tools and widgets and UI components here. That's usually modular software. That's separate than modular architecture. The architecture piece is about how we build the software, not how it's actually deployed or managed. And being modular is not about just following the Unix or Linux mentality or becoming a Linux guru. There are patterns that we can apply and learn from there and just apply them to our modern way of building software. So let me start with the Unix philosophy. And this is going back to 1978. So 41 years ago, when the Unix world was kind of just blooming, the folks who created the Unix ecosystem came up with these kind of 4 principles about how to build an ecosystem of software. And really, they summarized it in a very simple way. Back then, it was in the Bell Systems Technical Journal. At the time, 41 years ago, they focused on doing one thing well. They focused on making sure that the output of every program is something that the other program can receive as an input. We focused on the way we build and design software should be to enable us to actually throw things away and replace them in a fast and iterative fashion. Focused a lot on using tools to make sure that the programming effort is lightened on developers and team members. Those are kind of like the main principles from 41 years ago. So in today's world, we're going to talk about why are we talking about something from 41 years ago? Because really, if you think behind those sentences and those statements, it's really about the people. All these kind of rules and principles are to make software developers and engineers do better at their work and be able to facilitate and help each other better. So really, at the end of the day, it's more about the process that is defined through the architectural paradigms that you choose and the tools and the workflows that you adopt. So what does this look like in 2019? Talked about 1978. Let's talk about 2019. The same principles can be taken, perhaps with a bit of a tweaking of wording there. Let's talk about modules. So each module should focus on do one thing well. The output of every module instead of every program should be to become the input to another. Throwing away the clumsy part and refactoring is a big part of our day-to-day operations in any company, in any software practice. Refactoring is a thing, technical debt is a thing we also need to be aware of. And making sure that we're using tools, and we're actually using tools today more than ever to lighten the programming efforts and the programmer's work. And I'm adding another one here just to kind of carry forward the kind of mindset of the Unix philosophy here, which is making sure that the work you're creating and the modules you're creating are focused on being easily maintained by people other than the original authors. You don't want to always rely on the same group of people or the same individual who created a module to sustain it forever. You want to make it for others to contribute. So let's talk about those kind of practices and what they are. And the practice number 1 that I'm noticing in the industry or I'm advocating for today is applications should just be a collection of packages. And this kind of satisfies 2 areas of those Unix principles. Each module should be doing one thing very well. And if you think in a package ecosystem, in the package world, each library, each package you publish is meant to do just the one thing. At the same time, because it's a self-contained entity, it's easy to throw away and replace it without too much disruption to the bigger application that it's relying on. So what does that look like in actual practice? So in your source code repository, I would expect not to see anything, any code-related items there other than perhaps your package.json or whatever other package management solution you're using or programming language it relies on. You want to have your environment descriptions. You want to have your execution and deployment descriptions, but not the code itself. The code itself should be distributed into multiple packages that are just maintained somewhere else. Now, you can all have this as part of the same repository. I'm not here advocating for an avalanche of individual repositories, but you can have a monorepo if you want. But the point is, your application itself shouldn't have any business logic as far as the code is concerned. It should just be the collection of packages that come together to make the application come alive. So just to go through like each of those kind of points that we talked about earlier, when we talk about each model doing one thing really well, there's really no better representation of that than just the self-encapsulated package itself. And the output of every module should become the input of the other, and that's something that enforced upon you by design when you start going down a packaging route, because every package needs to have an API interface that's well described and well documented so that it can be consumed by another application or another package. So you're forced to make that kind of exchange of data and exchange of information something feasible and portable. Being able to throw away the clumsy parts, again, if it's a self-contained package, self-contained software component, you can replace it much easier than trying to rebuild an entire application just because your dependencies are very integrated into your app. And at the end of the day, this is where package management and tools around package management come to lighten the load, and usage of those tools make your experience a lot better for the developer, but also for the community of developers that might be relying on your application and development around it. Here's an example of some things you can break into packages just to kind of use some real-world scenarios. You might have a web application or an API. Typically, you would have everything in your code repository and all the modules, all the routes, or all the tests, all the functionality are just organized into folder structures. If you think of all these folder structures that you use for organizing your files into individual, self-contained, packaged code pieces or modules, then all of a sudden this starts coming together. I don't know if you can read that far on the left and some of the examples there, but you can have your own, every route can be its own package. You can have a route for users, a route for billing, a route for whatever functionality you're providing. And then equally, all the database modeling that you might be doing in your application can also be separated out into each model can have its own package independently. So you'd have the user model as its own package, the billing model as its own package, and then the cross-dependency between routing and models, and perhaps your unit tests are all associated with that, becomes all self-contained in one shape. Principle number 2, documentation. Again, the constraint of design by having to think of your code and your applications as individual packages forces you to go down this path, because the first thing a developer would look at or an engineer would look at is the documentation for that package. So you got to make sure you create contribution guides, create better README, create better workflow for the whole principle of other folks than the original maintainers or original creators should be able to easily jump in and contribute and or use the individual software module. Some examples that also count as documentation, and I'm not just talking about wikis. Your meeting minutes are documentations, your bug reports are documentation, your user stories are documentation. These are all things that when you start thinking of decoupling your big monolithic software into small modules, you want to have the bug report that relates to that one UI bug or one button issue associated with that code itself. But when you have that bug report as part of thousands of lines of code, as part of a big monolithic application, it's hard to keep that association going. But by breaking things down into modules, all of a sudden these things become a one-to-one match and relationships there. This is a bit controversial, but having 100% test coverage is a thing I would advocate for. Again, under the guise of you want to make things better maintainable for others to come in and be part of that story. So again, by forcing your thinking into how do I make this better maintained by others, you got to make sure that you're testing all the cases, testing all the edge cases, creating all the unit tests, all the end-to-end tests, all the integration tests. And what better way to group all that together rather than having this monolithic testing frameworks is by breaking your code itself into packages so that the tests themselves are smaller pieces of consumable stuff that developers can understand better. And finally, this might seem daunting, but at the end of the day, when you have so many packages as part of your code being broken down into so many modules, it might sound like you're going to be doing a lot of manual work on updating and maintaining all these things. But the good news is bots are here to help us. They're not here to take our jobs away. There's a Twitter screenshot there on the far left side of the screen. I don't know if you can read it, but this is a real case scenario. It happened where a bot found a dependency vulnerability. It opened up a pull request to patch it, and then another CI environment ran it to verify that the test doesn't break anything. And then another bot came in and saw that the CI was successful and merged it. And then finally, another bot came in and posted a fun GIF to congratulate the merge for happening. This all happened without human intervention. And this becomes a lot easier when you think of your software as independent modules that you're maintaining and allowing automation to step in and do the manual labor that otherwise humans would be doing. And this is a lot easier to deal with, especially for bots to understand what they're doing when things are separated into their own separate units as opposed to big monolithic codes. Just by data proof point, humans seems to love modular code, as the data shows us. This is a graph of a number of popular programming languages and the package managers behind them. So NPM is up there on the very top. We've crossed over 1 million packages back in, I think, June or July, and the number is still going up. It just shows that people are more thinking of that pattern of smaller modular code that is easier to maintain, easier to manage, and easier to share. And this is where NPM can help. Just from showing and learning from our users and what people are doing with it, we've created patterns that you can adopt for building modular software architecture and sharing it across your team and being able to collaborate even better with everybody. So again, if you're interested in that or interested in learning more, we have a booth at the end. I can tell you more about it. I have an even longer version of this talk when I get into more technical details at Node Day New York. I think that's happening on Friday. I think it's free. You can show up and talk more about it. It's more technical. We can get into more the nitty-gritty details of it. But that's it. Thank you very much.